All right, today we're going to pull back the curtain on a really powerful secret for controlling mainframe costs. And look, it's not all about raw speed. It's actually about the kind of processor you're using. And understanding this one thing, it can totally transform your IT budget. So yeah, let's dive right in. Okay, let me just ask you a straight-up question. When you picture one of those huge multi-million-dollar mainframes, what do you think costs the most? I mean, is it the actual hardware? The complex cooling systems? Go ahead, take a guess. You know, if you said hardware, you'd be in good company. A lot of people think that. But surprisingly, the single biggest and most recurring cost in the world of mainframes, it's the software. And really, getting your head around that one fact is the key to everything we're about to talk about.
Right, so that begs the question, why? Why is the software so crazy expensive? I mean, how can some lines of code end up costing way more than a whole room packed with cutting-edge hardware? Well, it all boils down to how it's priced.
And listen, we're not talking about a tiny difference here. The IDEG Solutions Journal actually puts it pretty bluntly. Software costs can be many, many times more than the hardware cost. And that right there, that's the exact problem that IBM's specialty processors were invented to fix. Okay, so here's the absolute heart of the issue. For decades, the way mainframe software licensing worked was tied directly to the processing capacity of your main engines. Simple as that. The more power you had, the bigger the check you had to write to your software vendors. And that's every single month, year in and year out. So to really get this, we've got to meet the main character in this whole financial drama, the central processor, or what everyone just calls the CP. This thing is the traditional do-it-all workhorse of the mainframe.
And look, the CPU is an absolutely incredible piece of tech. It's a total generalist. It can run anything and everything you throw at it. Your operating system, your core transaction systems, you name it, the CPU can handle it. But, and this is a big but, that amazing do-anything power is precisely why it's the main billable unit. Its capacity is literally the ruler they use to measure your software bill.
I like to think of it this way. It makes it a lot easier. Imagine your data center is a factory. The central processor, that's your general manager. Super capable, super smart, can oversee every single thing happening on the factory floor. But that kind of top-tier talent comes with a really, really high salary. And everything that happens, well, it's on their budget.
But now, what if you could bring in some specialized workers, experts at specific, high-volume jobs, and have their work not count against your expensive general manager's budget? Well, guess what? That is exactly the whole idea behind IBM's specialty engines.
And you know, this wasn't some flash-in-the-pan gimmick. IBM started this whole strategy way back in 2000 with the IFL, which was built for Linux workloads. Then, a few years later, they came out with the zIIP for Java and then the zIIP for databases. It shows this was a long-term, really deliberate plan to help customers finally get a handle on that monster software build.
Let's take the IFL first. It's designed to do just one thing, but do it incredibly well: run Linux. So by shifting all of your Linux work over to these IFLs, suddenly none of that processing power counts toward your billable CP capacity. It's kind of like, from a software cost perspective, running an entire section of your factory for free. Pretty cool, right?
All right, next up, we've got the zIIP. Now this one is a specialist for running Java code and parsing XML. You know, the basic building blocks of pretty much all modern web apps and services. What this means is you can modernize your big enterprise applications without just watching your software costs go through the roof.
And then there's the zIIP. If the zIIP is all about the application logic, the zIIP is all about the data. This is the engine that handles all the heavy lifting for database queries. We're talking about stuff coming from your BI tools, your ERP systems, your CRMs. It makes giving them direct access to your core mainframe data so much more affordable.
Okay, so just to recap, these specialty engines handle very specific jobs, and they do it without making your software bill balloon. That right there is a massive win. But believe it or not, the financial story gets even better when you actually look at the price tag on the hardware itself.
So a standard general-purpose CP, that's our general manager, remember, it's going to set you back roughly $250,000. That is a serious investment, no matter how you slice it.
Okay, now get ready for this. The cost of a specialty processor, our specialized worker, is less than 50 grand. This is the big aha moment. You get all this dedicated processing power that's basically invisible to most of your software licenses, and you get it for a tiny fraction of the hardware price. Just let that sink in for a second. We're talking less than 1/5 the price. And
And this is huge. It's a one-time charge. When you upgrade your whole mainframe down the road, your specialty engines get upgraded to the latest and greatest tech for free. The long-term value here is just incredible.
So you might be thinking, okay, this sounds great, but how does it actually work? Is it a nightmare to manage all these different processors? And the answer, thankfully, is a big, beautiful nope. The real genius here is how simple it all is.
See, all of these processors, the CPs and all the specialty guys, they all live together inside the same physical machine. And here's the best part, you don't have to do a thing. The ZOS operating system is the real brain behind it all. It acts like a super smart traffic cop. It sees a piece of work come in, say a Java process or a database query, instantly knows it's eligible, and just shunts it over to the right specialty engine. It all happens automatically, completely seamlessly.
So, let's go back to our factory analogy one last time. You haven't gone and hired another super expensive general manager, right? No. Instead, what you've done is install these highly efficient, specialized robotic arms on your assembly line. They do their one job perfectly, they boost your factory's output, and they do it all without adding a single penny to your management payroll.
You see, this is so much more than just a clever technical trick. It's a really powerful financial lever. So let's just boil this all down to the big strategic takeaway for anyone who has to manage an IT budget or look at a P&L.
Okay, here's the bottom line. When you use specialty engines, you are drastically lowering your total cost of ownership for those specific high-growth workloads. It means you can scale up new apps on Linux or Java without that constant fear of your licensing fees spiraling out of control. It means you can let your business intelligence tools connect directly to mainframe data without paying a penalty. You can even add capacity for new projects, which might let you put off a much more expensive full system upgrade. And, maybe most importantly, you directly, tangibly reduce your monthly software bill.
And all of that really brings us to the final thought here. For so many years, that constantly growing software bill was just a fact of life in the mainframe world. It was something you just had to accept. But with specialty processors, that's just not true anymore. So the real question you've got to ask yourself is this. Could it be that your mainframe's biggest cost is also its biggest and maybe most overlooked opportunity for savings?